Can algebraic expressions be divided by other expressions? Have you ever wondered if you can divide algebraic expressions just like you do with numbers? Well, the answer is yes. Algebraic expressions can be divided by other algebraic expressions, and it works similarly to how you would divide regular numbers. Let's break this down to see how it all works. First, when you divide algebraic expressions, you can think of it like working with fractions. The division symbol can be rewritten as a fraction bar. For example, if you want to divide 24 times a variable raised to the 7th power by 4 times the same variable raised to the 5th power, you can write it as 24 times variable to the 7th power divided by 4 times variable to the 5th power. Next, we simplify the expression. This involves dividing the coefficients, which are the numbers in front, and subtracting the exponents of like bases. In our example, dividing 24 by 4 gives you 6. Then, subtracting the exponents, 7 minus 5 gives you variable squared. So, the result of this division is 6 times variable squared. There are different scenarios when it comes to dividing algebraic expressions. You might divide a monomial, which is a single term, by another monomial. You could also divide a polynomial by a monomial or even a polynomial by another polynomial. When dividing polynomials, if you notice any common factors, you can factor them out and cancel them. If there are no obvious common factors, you might need to use methods like polynomial long division or synthetic division. These methods are similar to long division with regular numbers. Factoring is an important step in the division process. For instance, if you have the expression 2 times variable times b minus 4 times b divided by a minus 2, you can simplify it by factoring the numerator as 2 times b times the quantity a minus 2. Then, you can cancel the common factor of a minus 2, leaving you with 2 times b. Keep in mind that division can sometimes lead to a quotient and a remainder, especially when dividing polynomials, where the divisor does not evenly divide the dividend. In practical terms, dividing algebraic expressions helps simplify complex problems, solve equations, and analyze functions in algebra. Mastering the rules of division, factoring, and exponent laws is key to making algebra easier to understand. By breaking down the division process into clear steps, rewriting division as fractions, factoring expressions, canceling common terms, and applying exponent rules, you can confidently divide algebraic expressions and build a solid foundation in algebra.